Hey friends, today we're talking about probability. The probability of an event is the chance that it'll occur. A simple event is one outcome or a collection of outcomes. So let's talk about an outcome. It's the possible result in a probability experiment. The real world definition that we can go with is it's the way that something turns out, how it happens. So for a sledding trip, you're going to randomly select one of the four hats. Okay, you've got a green, a blue, a red, and a purple. Those are our possible outcomes. So if we wanted to write a ratio, remember what a ratio is? That compares the number of blue hats to the total. We would know that there is one blue hat out of 4. So describe a hat display in which you would have a better chance of selecting a red hat. Well, we would have to add more red hats. So for example, if we had maybe 3 red hats, well, then if we had another red hat and another red hat, we would have a total of how many items now? 1, 2, 3, 4, 5, 6. So we would have 6 items and 3 of them would be red, so our probability would be 1/2. So the probability of an event is the ratio that compares the number of favorable outcomes to the number of possible outcomes. All right, so when we're looking at these, I want to make sure that you have this chart written down. 0 is impossible. If it's got a 0% chance, it is impossible for it to happen. A 1 would be 100%. It's certain. It's definitely going to happen. And 50% or a half would be it's equally likely as it is unlikely. And each of these, as it goes this way, it becomes more unlikely, and as it becomes this way, it becomes more likely. So you need to have this written down and this chart. So when we're looking at these events, notice that the fraction cannot be improper. So you can't have like 5/4. Why is this? Because that means that it's more than certain, which doesn't even make any sense. The furthest that you can go is certain. So for example, there are 6 equally likely outcomes if we roll a die. Okay, find the probability of it landing on 6. We want the favorable outcomes. Okay, so 1 through 6 is labeled, so there's only 1 6 there. Out of the number of outcomes, if 1 through 6 is labeled, there are 6 possible. So the probability of rolling a 6, and we write it like this, the probability of rolling a 6 is 1/6. Try this one. A coin is tossed. Find the probability of the coin landing on heads. Write it as a fraction, decimal, and percent. Okay, so the probability of it landing on heads, make sure you write that first, equals, and your fraction, your decimal, and percent. Okay, I'm going to show you what I would do. We know that to land on heads, you have 2 options, heads or tails, and there's only one that you want heads. So this would be 0.5 because we're changing this one into 100. So this would be 50, right? So 50 would then be simplified to 5/10 or 50% because this is per 100. Okay, try these. The tiles spelling the words mathematics were placed in a bag. What's the probability of getting an M, the probability of getting an A or an I, and everything but an H? Go ahead and try that. I'll be back in just a second to show you what I did. So there are 11 possible outcomes when you spell out mathematics. 2 of them are M's. So 2 out of 11, and that can't be simplified. The probability of getting an A or an I, here's an A, here's an A, here's an I, so there are 3 out of the 11. And there's only 1 H. Do you notice that? So if there's only 1 H, then we can get all 10 other letters out of the 11. All right, find the probability of rolling a 2, 3, or 4 on a number cube. Hint, the word or indicates that the number of favorable outcomes needs to include 2, 3, or 4. So we write it like this, and we put the number of favorable outcomes on a number cube would be a total of 3. Out of how many? 6. That's not simplified. We can still simplify it to 1/2. So the probability of 2, 3, or 4 would be 1/2. All right, you try this one. The spinner shown is spun once. Find the probability of each event. I'll be back in just a second to show you the answers, so make sure you pause right now. Okay, here we go. There are 10 possible outcomes when we look at this spinner. 5 on this side, 5 on that side, so each one of these is going to have out of 10 unless we have to simplify it. So for an F, if we look here, here's F, there's only one possibility, so 1/10. D or G, we're looking for a D and a G, here they are. So for D and G, there are 2. 2/10. That can be simplified to 1/5. If we're looking for a vowel, we could have A right here, B, C, D, no, E, no, 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 and I. So 3 out of 10, and that can't be simplified. A bag contains 5 blue, 8 red, and 7 green marbles. A marble is going to be selected at random. Go ahead and try to find the probability of the marble being red and of it not being red. I'll be back in just a second to show you what I did. Okay, so hopefully you added these up. So 5 plus 8 plus 7, and that gives you right here 15, plus another 5 is 20. So there's a total of 20 possible outcomes. Our favorable outcome in the first one is the reds. So we have a total of 8 red. So 8 out of 20 would be the probability of getting a red, making sure that we always put P with the parentheses red. Now, that can be simplified. What number goes into 8 and 20? You might be thinking 2. So that's 4 out of 10. But that can still be simplified by 2, so 2 out of 5. So our total is 2/5 for the probability of getting a red. The probability of the marble not being red, if you know that this is 8, then it's got to be a total of 12, right? We have 5 blue and 7 green, so there are 12 total out of 20. And the way we write this would be not red. We don't put green and blue because they didn't specifically ask for those colors. They just wanted the not red ones. We can simplify this by 2. We get 6 out of 10. We could simplify that again by 2 and get 3/5. Now, if you found that you could have just divided by 4 and gotten to that step right away, that's fine too. I was just showing what typical answers might have been. All right, so Ms. Voss is surveying her class, and she finds that 30% of her students have blue eyes. So the probability of blue eyes in her class is 30%, or 30 over 100, or 3/10, right? And they want to know what's the probability that do not have blue eyes. So if we wanted the not blue-eyed people, we don't even know how many there are, do we? But we know that that would be the remaining 70%, or 70 over 100, or 7/10. Okay, and that's all I've got for you today. I will see you next time. Make sure you have all the examples written down.